Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family and my mentor, Professor R. Surendran from Government College of Technology. And thanks to Almighty my God, my friends, followers, my dear students and subscribers. Yes, we are continuing the objective type questions, but the subject is we are completed the engineering mechanics in previous videos. Now in this class we are going to start the strength of materials part 1 objective type questions. Yes, welcome you all once again. And now we are going to start the question number 1. Yes, very superb question. Young's modulus is defined as Young's modulus is defined as simply the Young's modulus is defined as stress by strain. Stress by strain. The stress by strain which is in longitudinal direction, that you have to mention. The relationship between stress and strain and Young's modulus is came from the Hooke's law. The Hooke's law indicates, it states that when the material is loaded up to its elastic limit, up to its proportional limit, we can say up to its proportional limit, the stress is directly proportional to the strain. Therefore, the proportionality constant is the elastic constant, and it is none other than the Young's modulus. That is why we call it as an Young's modulus, which is equal to stress by strain. But it is longitudinal stress by longitudinal strain is the correct answer. Please make a note. And there is no the option lateral stress by lateral strain. There is no other definition for that. Volumetric stress by volumetric strain, which is called bulk modulus K, and shear stress to the shear strain. It is the ratio about the rigidity modulus. We can call it as a C, G, or N, whatever it may be. Okay. I hope with this question we can easily understand the three elastic constants. So please make this question very important. And next question is, yes, a very superb question. A tensile strength of a material is obtained by dividing the maximum load during the test by, as we said, the in stress strain diagram we have a, if just an example, we use ms to do the stress and strain. Let me consider, so this is the tensile strength, so tensile strength is here. The tensile strength, which is equal to the tensile force or the maximum load in the case. So this is the ultimate point, is the maximum load point. The ultimate point sigma u, which is equal to maximum load divided by original area of cross section. The original area of cross section is the right answer. Yes, very superb question. Next one. The section modulus of a circular section about an axis through CG is section modulus. Please make sure that this is called section modulus, not moment of inertia. Please make a note. This is section modulus. Section modulus, which is equal to Z, that is I by Y. I, we know that pi by 64 d power 4, where y is the y is the y is the d by 2, you can say d by 2. So the answer is pi d cube divided by 32. As I once again I will make it, z is equal to m by I, where m is equal to pi by 64 d power 4, where I by y, which is d by 2. So here on d it is cancelled, and this is 2 and 64 it get cancelled. Therefore the equation becomes pi by 32. 64 by 2 is 32 and a d cube. So this is the answer. That is why it is coming like this. Okay. And next one is if the part is constrained to move and it is heated, it will develop. Let us assume the part is constrained over here. When it is heated, what will happen? The materials generally, if we increase the temperature, it will elongate, or we can say it will increase the length. If we make cooled the material, it will shrink. If the both ends are constrained to move, and if we are heating, what will happen? The material tend to extend, but since this is the fixed support, it will not elongate the material. So compressive stress is being acted. If it is cooled instead of heated, if it is cooled, then tensile strength will come. There is no principal strength and no shear strength. Okay. And next, the moment of resistance of a balanced reinforced concrete beam is based on the stress in the moment of resistance. The moment of resistance of reinforced concrete beam is based on stress developed in both the steel as well as the concrete. So concrete and steel both put together will resist the which will produce the moment of resistance against the stress. Okay. And the next question is very superb question. It is a material property, the property of the material by virtue which it can be beaten or rolled to plates. If it is beaten or rolled as a plates, it is called malleability. It is called malleability. If the elasticity, when we apply a load, the material tend to elongate. If we remove the load, it again regain its original position. That is called as an elasticity. If the plasticity is similar to the elasticity, but it will not regain its original position after removal of load, so that is called as a plasticity. Where ductility is in the case, we can apply a tensile load to make a thin wire shape. Is called ductility. Thin wire shape is called ductility. Plate shape is called as a malleability. Okay. Plate shape means malleability is always take a compressive type of a load. Next question is the energy absorbed in the body when it is strained within the elastic limit is known as strain energy. And next, fletched beam. The fletched beam is used to equalize the strength in tension and compression. Fletched beam is used to equalize both strength in tension and compression. And fletched beam have a greater stability under tension and compression. Okay. And very superb question. The percentage of reduction of area performing a tensile strength on cast iron may be in the order of. So percentage area reduction. You may notice this. This is a cast iron. We know that cast iron is a brittle material. And we are applying in tensile strength. Since it should be a very very minimal percentage. If there is a 0, we can straight away tick a 0, or if there is a very very minimal percentage, you please make that as an your choice. If you see there is none of this, you can take none of this, or 0%, you can take 0%. Since it is a brittle material, it only take compressive load, it will not perform in tensile load. Please make a note. If in the option, if you see a 0%, it is the correct answer, or none of the above, it is also a correct answer. And whatever the percentage is minimum, that can be a minimum percentage. Or sometimes we can say as a proof stress, it make a 0.2 percentage of the area. Therefore 0.2 percentage is nothing but uh, zero point 0.2 of the area of the stress, 0.2 of the stress. That is why it make as an 20 percentage. Maybe that may be an answer too. And next, a beam is loaded as a cantilever. If the load at the end is increased, the failure will occur at. See, this is a cantilever beam. So one end is fixed and another end is free. And if the load at the end is increased, if this load at the end is increased, the resistance is always at the fixed support. The failure is also occurs at the fixed support. At the support is the correct answer. And next, very superb question. The assumptions made in Euler column theory is the Euler column, it is for long columns. If you can see in the name itself, Euler. So L is called long column. Therefore, Euler column theory, which is also always used for the long columns. So the assumptions are the long columns will failure due to buckling alone, and the column material which will obey the Hooke's law, that is stress is directly proportional to strain, and the length of the column is very large as compared to cross section of the dimension. Therefore all the above are the assumptions of Euler column theory. And next, a very super question. A hollow shaft of same cross-sectional area as compared to solid shaft will transmit. You can see this is the solid shaft having an area about pi by 4 d square, and this is a hollow shaft having an area of pi by 4 capital D square minus small d square. If the both are equal, what will happen? The hollow shaft will transmit more torque than the solid shaft. If the areas are equal, then the solid shaft will comparatively will transmit low torque and compared to hollow shaft. The shaft and diameter proportion is this: the torque T is equal to pi by 16 d cube tau s, where T is directly proportional to d cube. If you increase diameter by 2 times, the torque is increased by 8 times of the shaft. In the area also, if you can see, if we are increasing the area or we are increasing the diameter, both if it is hollow shaft pi by 16 capital D power 4 minus small d power 4 divided by capital D into tau s. So tau s. So all our diameters are increasing. Since the diameters are increasing, it will transmit more power. So this is the proof. And next question: a steel bar of 5 millimeter is heated from 25 degrees Celsius to 45 degrees Celsius, and it is free to expand. The bar will induce. Please make a note that a steel bar is having 5 millimeter is heated from all the things are okay, but this is the steel rod of the same dimension and it is free to expand. If we are heating, what will happen? The materials, if we apply heat, the materials generally will elongate. If there is a free to elongate, then there is no stress is being formed. If there is a constraint, then the compressive stress is being acted. If there is no constraint and free to expand or free to contract, no stress is produced. So this is a very important question. Many of us may put the answer as a compressive or a tensile, but it is free to expand, so no stress is induced. And the next question, a very superb question. Two shaft A and B transmit the same power. The speed of the shaft A is 250 rpm and speed of the shaft B is 300 rpm. So A is 250 and B is 300. So they transmit same power, but what it is, we know that P is equal to 2 pi nt by 60. Therefore P is directly proportional to N and P is directly proportional to T, but N and T are inversely proportional. N and T are inversely proportionals. We can say N and T are inversely proportionals. If the speed increases, the torque reduces. If the torque and diameter, we know that torque is directly proportional to diameter cube. If torque is reduced, then the diameter is also reduced. So as per this relation, the shaft A has a greater diameter. The shaft A has a greater diameter. Since it is a low speed, since the speed is low, N is directly proportional to 1 by T. If the speed is low, then torque will be more. If torque is increased and the proportionality diameter is also increased, that is why shaft A has a greater diameter. Okay. Superb question. The intensity of stress which cause unit strain is called, yes, exactly, modulus of elasticity. Modulus of elasticity. And next, a very superb question. A vertical column has two moment of inertia, that is Ixx and Iyy. The column tend to buckle in the direction where it is having a minimum moment of inertia. The minimum moment of inertia side, the column tend to buckle. At the maximum side, it won't buckle. If you take a rectangular column, like this is the cross section as like this. Since the thickness is very less compared to breadth, it easily tend to buckle like this. Okay, so where the moment of inertia is minimum, on that side it tend to buckle. Okay, next, the strain energy. Strain energy is the energy stored in a body when strained within elastic limit. So that is called strain energy. And the energy stored in a body, the strain energy stored in a body up to elastic limit is called resilience. The maximum strain energy that can be stored in the body is called toughness, and the proof resilience per unit volume is called as an modulus of resilience. Please make a note of this. So this is a very, very important question. Okay, and a very superb question. The neutral axis of the cross section of the beam is that of the axis at which the bending stress is. Yes, it is 0. I would like to explain that. Consider a simply supported beam. It is supported at the two ends. If a load is acting, W over there, and due to the load, the beam will tend to buckle like this or underwent a deformation like this. What will happen? So this is the neutral axis when the stationary no load condition, and this is the neutral axis at the load condition. The topmost layers of the fiber will get contracted and the bottommost of fibers will get expanded. Tensile stress is acting here, compressive stress is acting here, and the center portion there is no stress is acting. So center portion there is no stress is acting. If the stress neutral axis, instead of bending stress it is a shear stress, it is maximum. There is no infinity, there is no minimum. 0 it is for bending stress and maximum is for shear stress. So please make a note, at the neutral axis of the cross section beam, if they are asking bending stress, it is 0. If it is a shear stress, it is maximum. And next question, very superb question. A composite bar made up of steel and copper bar having an equal length heated through 100 degrees Celsius. So composite bar, there is no constraints or given. Please take a note. So this is a composite bar. One side is made up of steel, one side is made up of copper, and it is subjected to a temperature. Generally, when we compare these two materials, the copper is softer one compared to steel. When we heat it, the copper tend to elongate more than the steel. The elongation of copper is more than elongation of steel. That is why the steel will make a compressive stress on the copper, and the copper will make a tensile stress on the steel. So the answer is tensile in steel and compressive in copper is the correct answer. If you are not able to understand this, if it is heated C to C, that is copper to compressive. When it is cooled, C to S. So compression to the steel. Okay. And the next, yes, as I said earlier, Euler formula holds good only for the long columns. So Euler means it is for long column. Euler means it is for long columns. And next, a superb question. The bending moment at a point on a beam is the algebraic sum of all moments on either side of the point. So it is a sum of all moments. And next, within the elastic limit, the stress is directly proportional to strain. Within the elastic limit, the stress is directly proportional to strain. And next, the deformation per unit length is called deformation per unit length. Please make a note, deformation per unit length is called tensile, whereas compression per unit length is called compressive stress. Sorry. So deformation per unit length. So deformation, change in length by original length, it is called strain. So it is a critical question too. Since the question is you have to read it carefully. Deformation per unit length. Yes, tensile stress is in the tensile manner, compressive stress in the compressive manner, where here they are asking about the deformation and length. So deformation is change in length by original length, which is called strain. Okay, a very superb question. Two closed coil helical spring of A and B are equal in all respect, but the number of turn in spring A is half that of spring B. The ratio of deflection of spring A to B is. Okay, so the deflection delta is equal to 64 W R cube N divided by C d power 4. If number of turn, if they are asking number of turn, so deflection is directly proportional to number of turns. If it is been halved, if number of turn is n by 2 and the deflection is also 1 by 2. So it is directly proportional. It is directly proportional. And I hope you have enjoyed the video. If you have any doubt on the above questions, please let me know in the comment section and I will put another video for clarifying your doubts. So if you like my video, please do like, share and subscribe my channel, and it will create a greater motivation for making more and more videos. I hope you have enjoyed my video. Thank you for patient listening. Thank you all. Jai Hind.